Welcome to part 2 of our Java New and Old. And for the rest of this, it's most likely going to be a lot more new stuff. And this is, again, not a in-depth review of the basics of Java. It's just giving you your first steps into learning a few more of the new Java tools that we will be using in this course when we talk about data structures and then implementing them specifically in Java. And in this video, I'll be going over Java interfaces and then generics, including some coding examples. Now, when this comes to Java interfaces, as I mentioned at the end of the part 1 video, I am not talking about GUI or graphical interfaces. I am talking about a Java-specific syntax and coding tool for their object-oriented design called interfaces. Now, an interface is a collection of abstract methods. A class implements an interface, thereby inheriting the abstract methods of the interface, forcing you to write them. That's a very general, open-ended kind of first definition of it. But I included an image here of kind of like the steering wheel. And this ties back to when I was first mentioning about classes and objects, and you think of the encapsulation of the internal and external view, and then having one object communicating through to the client object through its services that it provides, which is really, you can kind of think of it as its interface of how to work with the object. And if we look at vehicles, we're going to get all types of vehicles around the world, but in general, with cars and trucks, you're going to have a steering wheel. And that's your one way of interacting with the vehicle and knowing one part of how to control it and request services from it, from turning left, turning right, and not trying to run over cyclists. Now, when it comes here to being interfaces in Java, what this really is a way that you as a developer can define that, okay, I want to write a contract for objects in the future to agree to, or more designers and who people are making the classes to be these objects, but kind of like a contract of agreed upon services they will provide, which is the methods and their parameters and what they should be doing. And then with that contract in place, you can then go on and design an entire system where you work with something that's already saying that it's going to do those services. And in the future, other people then can then implement an actual class that does those services, being those methods, and then codes it and passes it to everything else. And if you've learned about coupling and cohesion, this more goes to the idea of coupling and being message coupling, which is really what we want when it comes to object-oriented design. That we want to really only be tied to another piece of code through the actual methods we call, limiting the number of points where we actually have to update that code if we make changes in the actual future. And also allows for more growth in design, the beginning to design a system with the methods that you need without having to have them fully implemented yet. So some common facts is that an interface is not a class, so it's not like the blueprint of what's going to be built. It is like a pre-contract of what has to be put into a blueprint when the blueprint is created. So it is tied to classes, but it's not like a class itself. Writing an interface is similar to writing a class, but there are two different concepts. A class describes the attributes and behaviors of an object, whereas an interface contains behaviors that a class has to implement if it's saying it's implementing that interface. So here's an example, and also what you do to start with. Is that it's similar to declaring a class, but here instead you are starting with the access modifier for accessing that interface or class within a package, so public in general. And instead of the word class, you use the word interface, and then you give it the name you want for that interface. So it's kind of like that's the name of this contract when someone else says that they're going to implement it, and also allows us to have a type that we can refer to, being like, hey, we know we have these services, and then we can work with any class that then says they implement these services. And when you define internally, you're not going to really see any instance variables. You will see constant, like public static const, kind of things there, but you will then just see the method signature with the semicolon and no actual body, which is kind of saying you will have this service, it'll be public, and these are always public, there's no real private ones you'll see, but it's public, the return type, your method, and the actual parameters. And then you as a coder will then define what that's supposed to do, and in part of the documentation let people know. And at the end of all of this, even after generics, there will be one small example of this. So an interface is similar to a class in the following ways: that an interface can contain any number of abstract methods, and an interface is written in a .java file. You may not be seeing this with whatever editor you're using behind the scenes. It keeps everything in the .java files. And the name of the interface will match to the name of the actual file it's in. An interface is not similar to a class in the following ways: that you cannot instantiate an interface. So that new, whatever example like cat, we can't instantiate it. We can have a variable that holds a reference to an object that says that it implements that interface, but we can't go new that interface. And it does not contain any constructors at all, because again, you're not creating, it's a contract of the services that you're going to provide. All of the methods in interface must be abstract, so meaning that they have to be implemented by the class that's saying that is implementing it, and they don't contain any body of code. And an interface cannot contain instance fields. Only fields that appear in the interface must be declared as static and final, so i.e. constants, like I mentioned. An interface is not extended by a class, it's that it's implemented by a class. And remembering that the being extended means you're inheriting from a class, so one class can inherit from another class. But now with interfaces, beyond just inheriting from other classes, a class can then say it implements this interface, saying I'm agreeing to provide these services from this interface, and then I will implement my version of it. And then any other code that says they work with that interface can then use my object and call only those services from that interface. When a class implements an interface, you can think of the class as signing a contract and agreeing to perform the specific behaviors of the interface. If a class does not perform all the behaviors of the interface, the class must declare itself as abstract. And that's going advanced. You can look into more into abstract classes if you haven't already. It's not exactly important right now. But really what this means is saying they're agreeing to do these services, and it's backed up by the actual compiler. Because if your object says it implements an interface, then the compiler will check, have you actually coded those methods. Now, the method could be blank and not do any work, but that's you as the coder have to do the right action that's required. But the compiler will at least check, do you have the exact same signature as defined for the method as defined in the interface? And is there at least opening, closing brackets, and a return statement if it says it returns something? So a class uses the implements keyword to implement an interface, and the implements keyword appears in the class declaration following the extends portion of declaration. But I've got an example in the next slide. So you can see example here, assuming that you have two different files. We have one interface here called animal that's saying it must provide the services eat and travel and have this return type and no parameters. We then now have a class called mammal that's saying it implements animal. And it has its own data, and so these other classes can have their own instance variables, can have their own other methods, say like here's a no legs, can have everything else you want from here. But since we have the words implements animal, it means we must actually implement all the methods that are declared in here. So that's why we've got eat and travel, and have some code that's actually associated with it. Now, examples when you actually go to code it itself. Here, and I'll do a live example of this again once we go through a little bit more of the code. But in the main itself, we can have things again like, hey, that original object mammal that we just saw here, we can then instantiate that and work with it as normal, call the eat and travel methods we had. Here I've got one line commented out, but if we uncomment that and try to actually instantiate something of the type of interface we're working with, it won't compile from right here. Now this next line, this is valid to do, and this is the way I say that you can have that some other piece of code wants to work with any object that implements that interface and then only cares about calling the methods that are defined inside of it. Then that's what this does here, is you just declare a variable, so it could be parameter, you can have a return type, whatever, of the type of interface, and then that can hold a reference, like we were talking before in the previous video, but it can hold a reference to any object that implements that interface, so as part of its design for its class. Then after this point in time, that reference variables of type animal can call any of the methods that are defined in the interface. Now, the original object that it could be holding a reference to could be for another class and have all the extra methods, but the idea here is because the instance variable is not of type mammal, but say of type animal, it can only call the ones that are defined in that interface because it knows that's the public services it can actually call. So that's why this line down here, where I've got it commented out for right now, of that a1.noLegs, this, if you actually uncompile it, it will not work, because when it looks at a1 dot, it's going to go look and say, hey, you define this as a type animal interface, and that number of legs is not defined in that actual interface itself. These last little lines down here is just an example that make it valid too, is that we can have animal2, which type of interface, and we can directly instantiate an object of the other one and save into this variable and start doing our work with it. So implementing interfaces. So a class implements, a class can implement multiple interfaces. You don't have to do it just based upon the one and that's one and done. All you have to do is add a comma between each interface that you are implementing. And there's another example coming here shortly. So if we assume that we have created these two public interfaces, right here is one called animal with the eat and travel methods, and one called killer bunny that has the one service eat people. Okay, like we have those two interfaces there, and that's perfectly fine to do. And now if we want to create a mammal that is both going to do the services of being an animal and a killer bunny, then all we have to do is again do the implements method and then go first interface comma the next interface, and you're just telling the system then, hey, these are the two that I want to actually implement. It must implement every method from here and from here, and that's why you can see the eat people, die, human die from this, and everything that we've done before works the same, that anything of type animal can hold a reference to an object type mammal1, a mammal, and anything of type killer bunny can hold a reference to mammal as well. Now, an important thing to think about is, like, why do we really need these? And am I going to be able to create a good argument right now of why you should use them and explain everything for the design in this short thing we have for this one part of this video? No. You have to go more into object-oriented design and play around with them. But we need to use them now because there's some things that are in Java where they've designed the libraries around using these interfaces, and you have to then know what you need to do to work with them. And even some of the code that I may provide to you will also require that. So why are Java interfaces used? Is capturing similarities among unrelated classes without artificially forcing a class relationship. So what this means here is that, well, if there's common features that I would like that should be services in an object, well, then I can create an interface and say they have to do the work, and then say you have to implement this in the future and agree to this contract, and it's set up by the system through that interface. And I don't need to force different weird relationships that would be through coders, that through the documentation you'd have to be told I have to implement and work this in every class, and I couldn't then change and switch stuff out. Declaring methods that one or more classes are expected to implement, revealing an object's programming interface without revealing its class. So the idea here is that, okay, I can design it, I can work with the services, but I don't have to worry about the specific person's class and their design until they have got it done and they've agreed to that implementation, and it works perfectly fine behind the scenes through polymorphism and everything else. They're also used to achieve total abstraction, being another key part of object-oriented programming is that you want to abstract away and have key things and just kind of compartmentalize and encapsulate to what you're working on and how you're designing stuff, and allow for easily flexibility of adding things in the actual future and extending upon systems. It's also used to achieve loose coupling, which again relates to the cohesion and coupling thing, and the coupling being, well, if I make one change, how is that going to ripple through everyone else? And we're keeping this to message coupling. Okay, so that is a lot there, and we've got Java generics as the next step. So before jumping too quickly into that, I just want to stop and go through another coding example so you see another practice of this yourself. So we'll switch over to Eclipse again, and I will go through just making a random interface example. I'm not picking one that's perfectly for design or the reasons. I'm just showing the basics of the syntax and steps you need to do to work with them. So I'll first create a new interface. I will call this, I don't know what I want to call, I'll just call it Bunny. I don't know why I'm on the animals theme, but it works for today. So boom, finish. Public interface bunny is what we need to have here. And now what we do is think in the context of like, well, we're going to design a system that's going to work with bunnies. There could be all different types of them, but we want to first, and not go for interface, we just want to have that they have to do some services to be a bunny from this. And so this would be the public things that we request from services from that bunny. So public, say void hop int spot. I'm just saying this is a hop method and telling it how many spots to hop. And let's say int direction. So if this is a game, what direction and how to spot hop from there. This is arbitrary. This would probably be better done through enums, but this is just a quick example of interface. Now let's say we do another one, int, and let's just say hunger level. So this will be a method that's supposed to return back the current hunger level of this bunny. And one last one just for fun, Boolean is alive. That will return back true or false if this bunny is still alive. So I've defined this interface. And the nice thing is I'm not going to make a class that's going to implement this yet. I'm going to go write some code that is going to use this bunny class, bunny interface. So let's say we start making a new class that's supposed to be representing an object that'll represent a game or a list of bunnies. So let's say bunny system. So this is not implementing that interface. It's just a whole nother piece of code that's going to work with that predefined contract. And it's going to keep, say, a list of bunnies. So we can have like private Arraylist. We can then now use our interface right there, saying we're going to keep a list of them. Bunny patch right here equals so making our array list. So it's the first thing now, because it's an interface, we can keep a reference to a whole bunch of whatever they actually are. We could make a public method then to say void add bunny, which then someone else has created it, and then we're adding it to the bunny patch. B. So forth from there. Public void hop, also move all the bunnies, int steps, int direction, do a quick for each loop. Well, I don't like the iterator one. I know that's auto-generated, but we don't need that. For, let's see. Yeah. Just do that quick one. You know, I'm being way too picky with my for loops now, and people are probably loving watching this. But it's all good. Oh yeah, it was for each. What was I thinking? For each bunny, go through each one right here using a for each loop, and then just say bunny dot. We can see the methods that are here, all the stuff that's from object, for everything else, and we want to call our hop method, and there we go, telling all the bunnies. So this is the actual bunny system. I can design all of this and do my work and call the methods off of it, and I have not even made any object that's implementing that, and that's okay. Everything will compile. Now from here is then, well, maybe I'm designing the system later, I'm a different coder or whatever in the future, and I want to actually start making different types of bunnies. Different things that'll say that they're bunnies or whatever else. And I know as I'm talking about this example, inheritance is probably a better design thing. This is just a quick example of stuff. But we will say ex bunny from right here. I'm just going to implement it. Now you can get Eclipse to auto-generate all of these. You can add the interfaces. I'm going to do the first one here just manually so you can see some of the steps. So as I type it, here's our new one. We want to say we want to implement that other class. Implement bunny. So our interface, it's going to start complaining because we have not actually implemented either of those methods or declared them as abstract. Get Eclipse to auto-generate it for me and puts them in place. So we can start doing whatever we need to do here for our class, and this is saying implementing it, and now it will compile. And that's one step of it. I can then make, say, another class, saying ex2. Just as a quick one, I can tell Eclipse to choose the interface I want to add. Bunny. Right here. And then I can make the new one, and it's generated, and it's already put in blank spots for all of the actual methods we need to actually implement. And then finally from there, if we quickly make a main, I can then start bringing examples of everything together. I can make a bunny system. Object. I can then start telling the system, okay, add bunny, new ex bunny. I can then also get it to add the other one, as fascinating as this actually is. And this is all legal, and then I can get things like the hop all, if I want to call it, so forth from there. Now, this is what I mean by this quick examples again of we can make the interface, do the methods, we can then go on to design a system that works with just that interface and finish our work, and in the future more things can be added that's saying it does that work by saying, okay, this is what we need from here. I'm not saying this is the best design things, that's a whole different thing in object-oriented programming to get into why we're using interfaces or how to design with them. This here is to show you those first steps of how everything works. And be aware, if you've gone over polymorphism before, this is one case where polymorphism kicks in, so that runtime execution or binding of what methods are called, the interfaces to the proper classes, and all of that said fun. Okay. So that's very quick, but don't worry, we'll get more practice on the task assignments and in tutorials and stuff in the future on this. This is just that beginning steps that I do suggest you go back, review the notes on interfaces, write your own, read a little bit more on it, write some code about it so you just get comfortable at least with the syntax and semantics of using them. And we'll get more practice as we continue on. Okay, next I want to switch back to the notes and now introduce Java generics, which is going to be hugely important when it comes to data structures. because we talked about in an earlier video again that data structures are about holding data, and it's not really first being important that you talk about one type of data it holds. It's just that it has data, and the structure allows certain properties of us to retrieve and access that actual data. And so what would be nice is having a way in a language so that we don't have to implement the same data structure for different data types again and again and again. We'd want a way that we can make a generic kind of placeholder and then pass in the type that we want to use later on. And trust me, this is going to be something that you've seen before and used. You've just not written your own generic classes, but you've used generic classes like the Arraylist class that we just saw. So Java generics, sometimes used as the plural noun generics, is a language feature of Java that allows for definition and use of generic types and methods, being that the type can be defined later on after the implementation, but during when it's instantiated and then used from that point onwards. This allows you to define a set of behaviors and data for a class where the type of data is not important when you are coding it. So this doesn't mean that generics are good everywhere and all the time, but there's certain situations, especially like with data structures, that it'll be highly useful to use generics. So the example that you've been using already is the Arraylist class. This is not a basic data type like an array. This is a class that was then designed that its main state is an array and its main role is to manage a specific array. So the adding, the removing, and the increasing of size and so forth of that. And that really then doesn't matter what type the array is, just it can do that work as long as it's storing and retrieving that data. And so this is where the original coder of the Arraylist class that's built into the library designed it as a generic class. And everyone here has had to have coded an Arraylist if you've been using Java so far. And you've generally seen when you've made it, you've always seen these kind of like less than or greater than brackets, and you've always putting the type that this Arraylist holds in between. This is an example of instantiating a generic class. And the idea is then we can use it for multiple types. So we can make one array list that is going to hold strings. We can make another array list that holds an interface like animal or class and so forth from there. So generics enable types, so classes and interfaces, to be parameters when they're defined in a class. So they can be passed in later on. So the types you want to use are passed in, just like you saw here that we have the strings and animal. Boom. Much like more familiar formal parameters used in your method declarations, type parameters provide a way for you to reuse the same code but with different inputs, i.e. different types, and you don't have to keep repeating the code again and again and again, just when you have to have a new type to do the same work. The difference is that inputs to formal parameters are values, while the input types here are types when you're dealing with generics. So enabling programmers to implement generic algorithms and generic classes and objects. And by using generics, programmers can implement generic algorithms that work on collections of different types, can be customized, and are type safe and easier to read when you're doing the code. Now, there could be some complications with that design, especially when you're writing code where you're ignoring what the type is, but sometimes you need to know more specific information and feedback. But that's where you get into interfaces and other stuff, again, being i.e. an agreed upon contract that'll be made. So sometimes you'll see generic classes that are required for you to implement interfaces to also do work with them to allow for specific situations where the generic code doesn't know what to do, but then when it hits that point, we'll call a passed-in object that knows how to handle that. And there is an example that we will go through here. So now with examples here like array lists, like we need to learn how to write the classes to do this. Like you've had the array lists, you've used it as an external standpoint of using an object and requesting its services, but we now need to also know how can we go to the other side as programmers and write our own classes that then can be instantiated as generic classes. And for the most part, it's not too bad. It just requires interfaces in some cases, and that's why I presented it before this. So how do you do it? A generic class is defined with the following format. is that when you're defining it, you include after the name and before the extends and implements phases, is that you include the greater than and less than signs, and then you start including your type parameters. And this is going to be different than your methods, because you don't have to declare a type like your parameter type. You just have to give a name. So here generically I've done it as a series T1 all the way up to N, because you can have multiple different ones that are coming in. But you have to define. I've got an example that'll show it clear. So really just want to define them in between here, and that's you're defining that we need these types to be passed in. It specifies again the type parameter, everything else. Okay. So here is an example. It's a longer one. I'll show some coding examples more with it. These dots are just showing if you had more. It's not specific to that. It's just a name that you're working with. So any type declaration in the class definition with that type parameter will be replaced by it after you pass it in. So when we're on this side, the idea is we'll see T, say T1, anywhere else in here where the type T1 is used. So for declaring variables, your instance variables, your return types, your method parameters, and so forth, it'll then kind of do a search and replace with the type that you pass in at the time of calling. So that's like right here where we're instantiating it, and you, not calling, but instantiating it, and then you have string that means, well, okay, that's the parameters being passed in, and everywhere within that class, the string will be replaced with it for that specific object. So for example, right here, let's say we have this basic box class. Nothing really big about it. It's just supposed to be idea it holds right now is just an integer data and say another variable that it needs to do its work with, and then you can set the data and you can get the data. And what you have to do here is like, let's convert this class that only works ints and turn it into a generic class so that it can hold any data type. So this takes some design to know what you need to change, and from right here, and we'll just say, okay, well, data is the generic thing that it's working with. Size it uses for its own specific thing, so it needs to stay its specific type, but anything else from there can be turned into generics. Now here you can see where I've highlighted in yellow. Well, this is the variable here, it's of type int, and we want to turn to generic, so this has got to change. Here's another point with set data where it's working with a data value, so that needs to change. And here's where we access and get it back, and so this needs to change. This one here doesn't need to change because we're like, in this example, it's only supposed to be the data is becoming generic, and this is something specific to the class itself. So here to start defining it, we make the class, we add the angle brackets, and we're just creating one type parameter. And I'm calling it T. It doesn't matter what you really call this. You could call it Farfanugan. You could call it Bunny. It doesn't matter. It's just kind of a placeholder for that first one. If you want to have two types that are passed in, you put a comma and then you put another name. And now down here where we had this ints before, we now put T, so it should match up exactly to that. And same for parameter and same from here. And voila, we have a generic class that then expects to be the type will be passed in for parameter when it's actually created, and then it'll create a specific object memory to work with that type upon instantiation. So here's an example. Make a reference variable, and this one can hold box objects that hold strings. And this next step is then creating the same thing, so instantiating it. Here's one where it then say uses another class that's called person. So this is a box that can hold a person, boom, and we create a new object of that type passing in here. So just like your Arraylists. So similar to passing in parameters when calling a method. So passing over here, and reference variable declaration and object instantiation need to provide the type from there, otherwise it may complain about things. So not too bad from right here until you get more practice doing this. Now here's an example with multiple types, and I'm using a different name here. So in this case it's type 1, so the big box. Big boxes can hold bigger things. And so you got type 1 and type 2. And you can see this one here contains, we have original box, and we're passing this type. So showing you how you can even say the generic types for other generics inside of generics at this time. But we have one here, here's type 2, get data, this returns type 2, and just all based upon what you want to work with. And so we have here is say the name, let's say string and person and string and person, and so this is up to the coder. So giving us this generic design of what we're doing, this containing of data and working with it, and writing your own generic classes for the basic syntax wise and instantiating them, not bad. Knowing when to properly design a class to be generic is a different thing, but it can take some practice, and like we'll get a lot of it in this class, more for the sense that we're working with data structures. Every data structure that we either use or create will be of generic type for just this course. So here is an exercise. I have uploaded the code and solution for this in a separate exercise document as well, and this is not for marks. This is purely just practice for right now, and this is just us giving another bigger example. And one issue that's going to come up from this exercise is that one of the questions is going to require that the generic class compare the data type, but you don't know how to compare, because if it's objects, you don't know what the object is that could be used in the future, and you can't presume what surfaces that are there. And so what we're going to do is use what's called the Comparator Interface, and this is an interface that's built into Java for comparing objects. So it's like a pre-defined agreement service for a method for how to compare objects that you can then use in your design, saying I'm going to use this contract and force other people to implement that, and being very common, it makes it easy for objects and start building from there. So, and I'm also like at steps of the code and solution, everything here, and I'm going to do more of these things live from live as we go through it from the coder, and then these notes will cover it more. Okay, either way, going back. So what is a Java comparator? Again, built-in generic interface. So we're now leveling up on how much we stack these things together, that classes are not the only things that can be generic. You can also define interfaces that are generic as well. And so this is built into the actual libraries that come with Java, and this is its general definition. So comparator, the type, you have public int compare, and it takes in two objects then of that generic type and returns back an integer. And in the definition of that interface, what it says that you should be doing, and everyone else will agree that this is how the result should come back, is that a negative number, so any negative number is applying back this comparator, says that object 1 is less than object 2. If you get a 0, it means that they are the same, and a positive integer means that object 1 is greater than object 2. So giving us ways to compare it and getting a numeric value back. How that comparison done is differently, but we have to agree to do this syntactically in the class, and then we also agree semantically that whatever way we do to compare two objects from what we're creating from a class is that we then return integer values that follow these rules. So a comparator interface is used in order for objects of user-defined classes. This will be very useful with generic classes when you need to compare data but don't have the code beforehand for those specific types. So if this is, say, a student or a person class and there's more information, it's more complex ways to compare, you can still write your generic kind of data storage class from it, and if you need to do comparisons like sorting and ordering them, you can then just say, oh, I need a comparator to do this, and so you can force them, say, through a parameter or something else to pass you in a comparator, and it's up to then whoever's using your class to code the proper comparator and agree upon that interface. Weird thing to say, but we'll see this throughout the code. So first off, before we even get to the actual comparators, we have question 1. Convert the following class to a generic class that accepts a single type for both field / or instance variables. So we have pair, you have first and second as private instance data, your state. You have a basic constructor where it's setting values, so 0, and this is presumed initialization due to the type of int. You have the next another constructor for setting things, gets and sets, and some other methods that work with it. Now here what this means, and the idea of pairing is, say, like these are two ints and can be paired together, and we want to turn this into a generic class that then we can put two objects and say that they're paired together, which is actually done sometimes, especially if we go to graph design and building. So, and that's the graph data structure I'm talking about, not graphs drawing. So here with pair, the idea is we need to check generic type. So we know we need to change it so that it has these things. I don't know why I'm doing here. Let me switch to the actual code. Would be a lot smarter, a lot more helpful for the people if I go there. I'm going to remove the said bunny system that we had before. Boom. Okay, and we're back to this code example. So now all of this code has already been uploaded to the Blackboard page and to the Google Drive and so forth, or wherever it's currently being uploaded to. And we have the pair class. So now we need to convert these over, and we have to do it that it's one data type used for both of them. So first step is name class is the less than or greater than signs, and then we need to give some name for our parameter type. I'm just going to call it type. I like to put it all in all caps. It doesn't really matter if it's all caps or nothing else. It just has to match wherever we're doing it. So first step is we want to then now, instead of we put type here so it's replaced, and type here for the instance variable. So we now both of them will be the type that's actually passed in. Here we're getting a little error because now we can't do default assigning of values because we don't know what the type is. Before it was int, here we don't know. So for right now, if you have no more guidance, we're just going to have to remove that code and leave it that the default constructor here is empty. And we can even just remove the default constructor completely because it's blank for now. This next one, we need to again say, okay, if we're passing them in through the constructor to set them, we change the int over to type as well, and then we should be okay. And then we're just going basically through the rounds. Okay, the set methods, same thing, type, 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 and type. So none of this is me just replacing all where there's ints. It's specifically because first off, I made these generic, then I was going everywhere where those variables or instance variables are interacted with and checking what needs to be changed or modified for that actual design, and all of these match up right here. So we're done. That's converting this class to actually being generic. If we went up to here, we can see now that if we were instantiating, say this in the main, where before it was generic and it was this type of 1 and 2, well, now we need to start defining things differently. So if I wanted to say this still pairs two integer numbers together, I can use the built-in integer class, which works weirdly as a wrapper. Right there, and then we are okay. Roughly. But say we even want to change that we want to pair a string and a string together. We can do that. Why is this complaining to me? Oh, why did I do that? That's why everything wasn't working. I got way ahead of myself of being a double parameters. Look at your teacher screwing up and live coding screwing up, but I think that's perfectly fine, and I ain't gonna cut that out because we all make little mistakes in life and we can fix them, and especially then in coding and having that checked. The difference would be people screaming at their computer right now that I should have typed it and fixed it, but maybe that's part of the fun. Okay, so we got string and we got string, and everything is wonderful and great now, and we've made our generic class. So let's pair. We have the one type right here. It's everything else, and now it's generic, and we can keep making whatever ones we want. We had one there as string. Let's now go properly and do one that's for integers. And that's perfectly fine too, and we can keep using this and reuse it to our heart's content in the actual future. So not so bad right there. Switch back to the slides for a second. The slides themselves right now, you can see this is the solution like we just solved here, and we'll go on to the next one. And now this is the one that's a little bit more complex and just throws an example of having the requirement for the comparator. So this first one now is we have a new pair class with a slight addition to it. Right here. Ooh. Okay. Oh yeah, this is with two types. So I was getting ahead of myself and thought it was the next question. And look how fun this is going, making videos all day. But first, question 2, convert the pair class once again to a generic class that now accepts a different type for each of the field or instance variables. So int first, int this, so same one that we had, but now we want to have 2 that are done. Switching back to coding it live. This doesn't change much right here other than I can say type 2, giving it just some other random name. And then this is going to be for the second type. So everywhere the second variable is, don't need it here, type 2 and type 2. And there we go. Now we can have 2 parameters passed in. We can have pairings of 2 things that are completely differently. We can go back to the loader here now and we could say add in, change this one to be a string and an integer. Right here, and this could be an integer and then a double or whatever else you would want. And making sure that here you got the string and integer on the declaration of the variables and everything, and you have it here and point 2. And now that's perfectly valid to do. Okay, back to the slides, and I will do a better time of not going so fast through the next example. Now, this is the question that we need the comparator for. So now another final pairing class. So your challenge here is to convert the following class to a generic class that accepts a single type for both of the instance data variables. So it's like that first one. Seems like, hey, we just need to do the generic things, change these types, take this out, same thing here. But what's the bigger difference is down here, there is a method called isSame. And this is supposed to return true if both the first and second contain the same data. So being that they are the exact, not being that they're the exact same object, but that they contain the exact same information. When this is ints, this is easy enough of doing a Boolean expression here that will result in true or false if they're equals and returning it back. But when we go to generics, there's going to be an issue. And so that's where we need the comparable interface to come up. But we'll start doing the conversions from there and then going to implementing our own specific comparable when we actually need it. So we got the pair2 class. We'll start the first thing by putting in the generic type. Taking out this constructor because we don't know, like again, we don't know the types it needs, how to set stuff, so we'll just take that out. And I'm just going to take out this constructor since it's blank anyways now due to taking those out. Change over this constructor. And now when it comes down to this, we need to properly change this over. Now, one problem here is, if you notice, it's still compiling and it will work, but we need to have a different way to actually deal with this comparing of the actual objects of the data that's inside of it. And we can't just go the equal sign. It may not work properly for us. We're going to need some other object to tell us how, okay, compare this for us. So you need to request a service from another object, say, compare this for us and give us back an actual result. And then we can reuse that result to do our work. So as I said, we can use the comparator interface. Comparator. one I want to do. Now this is a generic interface, so it expects you to pass in the type. We are just going to get it to pass in the generic type that we're given to our class, saying that that's what we want to compare from it, and CMP. I'm going to give it a random name. I am not going to create it now because remember we can't instantiate interfaces, but we now have a variable that can hold anyone who says they implement that interface. We are then going to force that, okay, for this class to work properly and compare, we need another object that can do the comparing for us, ready to go when the object is created. And so I'm deciding right now is that in the constructor to force them to pass in an object of this comparator that compares our type, and then force them that they have to give that to us. Now, maybe they code it wrong, but that's not our problem here. But we are getting out of that, okay, this is us forcing, we have it here so that we know, okay, well, I've got this here. I know that because this is the only constructor I have, they have to call this, and it forces them to pass in the comparator, so I will have it. And so now when I come down to the is same, I can now compare the first and second. I'm just going to comment this out so I can have our reference. And remember that to compare stuff, it's always CMP, and you've got the compare method right here, and you pass in the two you want. So say first. Let me just do that again. Boom. And so this is us requesting that service. We don't know which object specifically doing that, but we know it's someone that did this interface who agreed to that contract. We know that the method's in here. And what we know that is that if these two are the same, this method needs to return 0. And that's because the documentation from the actual code. So what we can do is go return and then just go equal to 0. And to make this a little bit more readable, I'm just going to add the brackets right here. So now this is equivalent to this, except for I don't know how to spell return when I type too fast. But now we have cmp.compare2 first and second. We know that this is supposed to return 0 if these are the same, so we compare it to 0 and return it afterwards. And so this is this kind of everything from these notes now coming together. This is the interfaces, the generics, the objects, the object interface, everything that we were talking about coming here, working together, is that we have one object, our pair2, that's generic from right here, requesting a service from another object saying, hey, I need you to compare these two objects for me. The agreed upon way that they're communicating for data coming back is that 0, -1, and 1, and so it's taking advantage of this. Now, since this is now generics, that this is a type here, that whoever uses this afterwards in storing their type will then also need to implement the comparator interface in some way, or make their separate ones, and then pass it in so that at this point in time it can compare it. And allows still that this is still very generic, it just allows a little bit more work on the other person's job that's making it. So if we go back to the loader class now, you can see these aren't working at all yet, but we can start by saying, okay, integer right here. I'm just keeping it as ints for right now. And I'll copy this so it goes faster. Change the next one. So we're doing it the proper way to get this compiled. We're doing the generic classes. Now this is still complaining because we need to pass in that comparator. We can't instantiate anything yet. So you could do it in the same class, but I suggest keep this all objects. Is I'm just going to make one small object that's separate for doing the actual comparator. So I need to make a new class that then implements the interface agreeing to do it, and now we'll do our specific comparison. So I'll make a new class here. I will call it integer comparator. I will then add core interface from java.util here. I then will go finish so that this will automatically do it. We have the implements, the comparable interface right here. Now here when you've got the comparator and we're making ours, we can say the actual type that it's saying there now. So, because again, it's generic, and so I don't want to also make this generic. I want to make it that it's implementing the comparator interface specifically for integers. Okay. All right, here. It's now still complaining because we haven't implemented the actual method here, so we can add the unimplemented methods that we're supposed to override to get this done. And now we can do the rest of the actual coding to get this right. And so now we know they're integers, and we can just go through deciding the results. So int res equals 0. Assume that they're the same in the very beginning. Then we'll go if O1 again is if O1 is less than O2, and me, just to be careful because I know myself, is I could screw up. We will go back to the notes, which is always good when you're dealing with this. Look back at the API and make sure the interface that we know a negative number. So if object, the first one is less than the next one, it's a negative number. 0 if they're equals, positive if O1's bigger than this. Okay. So back to our code. O1 is less, then we say result is equals, say -1. Could be any negative number, really doesn't matter for here. Else, and then we will take this and switch it around. Greater than equals 1, and then we'll go res. Now, why I'm leaving out everything is to shorten the code, not having to do all comparisons. I am setting the results to 0 in the beginning. I am checking then is O1 less than O2, then it's -1. If O1 is greater than O2, then it's got to be a positive number, so it's just 1 to make it any positive number. And you know, logically for the 3 steps, if O1 is not less than O2 and O2 is not less than O1, then they must be the same. And so that's why I defaulted to 0 here, and I'm just returning that back. So there we go, implementing our comparator interface. So implements comparator, setting the type for, since it's a generic interface, coding the method to following this the recognition, and then we can come back here in our loader, and then we can have it right here. So we can go new, my computer's slow when I try to record and do everything here at once. There we go. New integer comparator, and then new integer comparator. I'm just being lazy by not using the same object and putting this straight into the definition right here. But we're passing in now the object that will do the comparison for it. And so now, get everything, see if it's complaining. Why is it complaining? Okay, fine. Casting, other stuff, just forgive me. Comparator, I'll just make a variable to store it. Should have done this in the first place. Integer equals. And now it's passing in the reference to the same one. Here, what it was complaining about, and hopefully this fixes it once I'm actually done. Let's see everything. Let's hope I didn't screw this all up. Let's go back to pair 2. Comparator of the actual type. Boom. That's passed in. That's passed in. We have the actual loader. Integer, 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 integer. chapter. Okay, why are you still complaining? Oh, I always love the live coding with last practices. Boom. Give me 1 second. Okay, for you, that was a very short time. For me, that was some embarrassing time. It was complaining because I hadn't saved the pair2 file. I just didn't go Control S, and so it was screwed up and not knowing what to do. And everything is okay now. And I feel more embarrassed, but whatever. We've seen that already in this video, and I am fine with that. So again, now we're back to the actual comparator. We've made it, we've passed it in, and we can now go on to run the program. And see from here that we get the first one where it's 1 and 2, and then 2 and 2. The first one says false, the second one says true is what's passed in. So I apologize for that again. The problem was I just didn't save this file before going over here, and it was complaining about this, which was confusing me, but now we're all good. So I have my comparator, and we are all good here. And passing it in. So go back to said notes. Right now. So again, within the code, it was here. Now we run it. We can see the false and the true for the 1, 2, the 2, 2, passing things here for the code itself, and we are good. The comparators, everything's passed in. We've made our generic type class. We've dealt with the weird issue of these comparing both of them, even our teacher being kind of weird when showing live examples, but that's perfectly okay. And this is a bigger example for now, but we'll get more practice in labs, tutorials, and future tasks of using this. This is just your first introduction of it, and then you should practice with this a little bit more and ask me for help on any questions or things that you may need from there. From here, I believe that was everything else now, and we are done your basic Java introduction. So this is just for the new features. Gives us about 2 hours of material that we have gone through, at least in the videos, and we'll have practice and tutorials. So from now, you should go back and practice a lot of these things, get a little comfortable. You don't need to be perfect with them. You'll get that on the tasks and assignments and tests in the future, but you should still be reviewing your previous Java material, looking back to previous assignments, getting used to the actual syntax, and reviving those older memories you may have for coding. Other than that, I hope that you're all doing great between your classes and the start of this earliest time, and you continue to be great.